Hey guys, Jarret and Quinton here. Our final project is a physics library that takes some of the laws of physics that we learned in Physics 1A specifically and applies it using SFML in C++. Uh, our initial plan was to have a much larger project that covered a wider scope of physics, but as we started working on it, we started to see pretty quickly that that was maybe a larger project than the time was going to allow for. So far we have a kinematics class that allows us to apply the equations from physics, and then we have a position class that takes those equations and uses SFML to animate those things on screen. And we'll get to the code and a demo of that in a second. But the first and most important part of this project is the splash screen, which Quinton will introduce since he worked his ass off on it.
So arguably the most important part of this project is the splash screen. And it's also drawing a background in SFML, which is the Dave Station logo that you see there. And this button here is its own separate class. And all I'm doing here is just like a little animation trick inside of SFML. And when you click start, it'll set that to close and the program can begin.
So once the splash screen goes away, as you can see, it then shows these two balls moving around on screen. So this is the code for our splash screen. I don't think we need to get into too much detail about what's going on here. It's showing a background image. There's doing some things with the mouse to make sure that the mouse is detected, right? Quinton, do you want to add anything to that about how the splash screen is working?
Here I'm using the rect class inside of the rectangle button CPP in order to determine whether or not the user's mouse is actually inside of the area of that rectangle. So that's why when you see me scroll over it, it expands a little bit and turns blue. So that's just how I'm keeping track of where the button is and also whether or not it's being clicked while it's inside of that area. And that's what we're doing in order to set the splash screen open condition to false, which closes it, and then the actual program can run.
Great. So from there, we have the kinematics class. There's a rectangle button that's also a part of it. Quinton kind of explained that in his intro. So there's a kinematics class, and this is where we get our kinematic equation. So what we're doing is we're running an SFML clock in order to track the time, and we're tracking the time as seconds. When we take in and create a kinematics object, we give it an initial position, initial velocity, and acceleration. Those conditions are placed into a formula for position, just like you would do in calculus or physics. This initial position times velocity times the elapsed time of the clock in seconds times 1/2 acceleration times time squared. And we didn't bother using the squared function, we just used time times time. We have a get velocity function as well that will go into the position function, and that will be used for in later iterations when we have momentum as a thing. When we're getting elastic collisions, we can reflect the acceleration. So yeah, that's basically that. The position class then goes ahead and it calls the objects from the kinematics class, and it's able to animate them on screen. So as a demo for today, we show our splash screen, which after a button click gives way to a hard-coded kinematics example. You'll see one ball in red that's demonstrating projectile motion. So that ball has been shot at some initial velocity, and gravity is going to take over. So you'll see it going in the air, up and up and up, and eventually gravity will take over, overwhelm the velocity, and it will begin to approach the ground. It'll also go off screen in the process. The other ball that you'll see is a blue ball, and in that case, what we're using is some equations, very simple equations for parametric motion using the C math library. So what we have is an x is equal to a radius times a cosine of t, and t in this case is the clock from the object from SFML, and the y is sine times the radius. And so you'll see that that object is making circular motion around a common point, which is the origin. And we're still working on getting that to be able to move away from the origin. The other thing that we're still working on with this project is collision detection, and we'll talk more about that after I demo this really quickly. So again, you'll see that this red ball will eventually go off the screen, and that blue ball is orbiting point at the origin. We also have something set so that way as soon as the red ball hits the ground, which it's doing off screen, it resets and starts the clock over and keeps displaying that movement over and over again. That's not our end goal, but it's what it's doing right now as we're testing still. A few more. We're on target with our kinematics. We're not quite on target with our momentum class yet, but I do think that we'll be able to hit that. Do you have anything else you want to add, Quinton?
Yeah, I think as far as fallback plans go, I think we might end up trying to implement something almost like maybe being able to click and drag a ball and launching it at like a wall, which would be maybe the border or something else, and just having the resulting motion occur from that, or maybe something else. We're not 100% certain yet, but we do plan on finishing kinematics and getting some momentum, and we'll see from there on what exactly this will end up being in total.